Most people interact with AI every day without understanding what happens beneath it. And that's not because AI is too advanced. It's because no one explains the fundamentals in a structured way. So, in this video, we are going to break down AI into the 6 core functions that make any intelligent system work. My name is Dineo, and my background is in education, ESL to be exact. Not computer sciences, not DevOps, or even coding. And my objective is to explain AI simply without assuming that you have a technical background. So to keep it simple, we will follow a warehouse robot doing real tasks, and each of its abilities maps, giving you a clear, practical understanding instead of abstract theory. And we will begin with the robot's most essential input, vision. And now that we're inside the warehouse, the first question is simple. How does the robot know what it's looking at? This is how a computer sees, but unlike you or me, it doesn't see colors and shapes.
Image becomes a grid of pixels,
so every
and that grid gets analyzed.
A grid of pixels. That grid then gets analyzed by a system called convolutional neural network, or CNN for short. So think of it as a team of detectives. So the first detective scans for simple lines, and the next one uses those lines to spot the shapes. And by the time it reaches the final detective, the team can say, okay, now that's a package and not a human. And this is how our warehouse robot knows what's on the conveyor belt. Factories use computer vision to spot microscopic defects on thousands of products a minute, things that a human eye would normally miss. So vision alone isn't enough. But what if you want your robot to listen? So seeing the world is one part of the job, but the robot also needs to respond when humans speak. So let's add its next sense, hearing. When you speak, AI doesn't hear words, it hears waves of pressure. So it turns those waves into a visual map called a spectrogram, which is more like a fingerprint of your voice. So it's like reading sheet music. So every note and pattern means a specific sound, and the system learns to predict what word comes next, one beat at a time. And now the robot can understand voice commands from its human supervisor, exactly like Siri or Alexa interpreting you saying, set a timer for 10 minutes. So speech recognition converts words or sound into text, so other AI systems can act. Hearing sounds isn't the same as understanding them, and that's where language comes in. Turning sound into text is very useful, but understanding meaning is a different challenge entirely. And that brings us to the robot's ability to interpret language. So once speech recognition converts sound to text, the natural language processing breaks it into tiny chunks called tokens, and each token gets placed on a vast mathematical map, an embedding, a space where words with similar meanings sit close to each other. So words like priority or urgent might be neighbors, while a word like banana would live very, very far away. So it's like a Google map for language. So every word has coordinates based on meaning. And that's how Gmail's smart reply and Outlook's auto suggest knows to suggest thanks for the update instead of see you soon. It's not guessing, it's understanding. Now the robot can see, hear, and understand. But how does it think? Once a robot can see, hear, and understand, it still needs a way to improve, to make better decisions over time. And that's where learning comes in. That's how machines learn from data, mistakes, and rewards. So the robot acts inside of its environment. When it takes an action, it gets feedback. For instance, if it succeeds, it gets a reward. And if it fails, it gets a penalty. Over millions of trials, it learns what works, just like humans do, but faster. So in our warehouse, machine learning teaches the robot to find the most efficient route between shelves. So the most common example you see every day is Netflix's recommendation engine. So its goal, its reward, is to keep you watching. So it analyzes your data and gets better and better at suggesting the shows that you like. But not every decision can be learned. Some need rules that can never bend. Learning is powerful, but the way house also has rules that can't be broken. Some behaviors have to be consistent every time. And that's where fixed logic steps in. So this AI mimics a human expert, but without the risk of them having a bad day. So it runs a check against a knowledge base of fixed rules, and it uses an inference engine, which is the part of the software that applies the rule, to ask a question and draw a logical conclusion based purely on that rule. So think of a doctor who follows a medical checklist. So for instance, if symptom A and B are true, then they should test for C. In our warehouse, expert systems ensure safety. So there will be no movement if a human is detected in this zone. And even if machine learning wants to keep optimizing. In medicine, expert systems analyze millions of cases. So if a patient shows rare symptom combinations, it can instantly flag possible diseases, giving doctors a powerful second opinion. And now that the robot can see, hear, think, and reason, it's time to move. At this point, the robot can sense, understand, and decide. Now, the final piece is the one we actually see, and that's movement. So robotics is the body that brings AI to life. The AI brain makes the decisions, and robotics makes them real. And this is the physical machine that executes all the brilliant decisions. And those decisions become commands that are sent to actuators, which are the motors and pistons that turn code into movement. Now, when the robot decides to turn left, robotics executes it. So it steers, it lifts, and it sorts. And the same principle applies to self-driving vehicles. So the AI interprets its environment, but the robotics, the actuators, are what actually steer, brake, and move through the world. And that's the magic. The 6 pillars working together, sensing, thinking, and acting. So to create intelligence that feels human but is not. But I want us to zoom out and see the full picture one more time. So let's just see AI stripped down to its 6 moving parts: the eyes that see, the ears that listen, and the mind that learns, as well as the body that moves. You now understand not just what AI does, but how it achieves it. From the CNN filters in computer vision to the reward system of machine learning. And now if you want to see the heart of AI's learning process in action, tap here. And I will walk you through how machines actually learn from mistakes in a full deep dive that connects directly to what you have just watched. So go ahead, click the video, and I will see you there.